So let's start with talking about the history of IT. Since it's a huge field, right? We're not going into much details, like I said. We don't want to overwhelm you or bore you because, like I said, some of you are here just to learn about the different fields of IT, which one you should choose and stuff like that. So we will cover history of IT in terms of, let's say, internet revolution, data and digital footprints, and the fields of IT that you can find boot camps for. So as you know, I will have a list of professions in IT, just a short list. As you will see, it's a huge area. So we don't want to go into the much details. And like I said, you guys are interested more in because in the fields that have a boot camps for, right? So that's what we will be concentrating on. Okay. So just the history. The internet, maybe you know, maybe not, has started in the 1960s as a way for government researchers to kind of share information. And because the computers in the 1960s were too large, which I will show you the image of in the next slide. In order to make use of information stored, let's say, in some other computer, nowadays, how do you share the information? You can just use the internet, you can just send it through email, or you can just copy some data from other computer in your flash drive, what we also call flashka. We just copy it and stick it into the other computer, and you can just copy the data, right? But in 1960s, computers were really huge. So in order for you to be able to copy data from one computer and to another computer, you had to do two things. You had two options, basically. Either they're going to send you the data, which were in a big tapes. You will see the picture in a little bit. Either they had to kind of ship it by postal services so that you can copy the data from that tapes, or you had to travel with your tapes or whatever to the site where the computer is, from which you would like to copy information, basically, right? And another spike, another catalyst in the formation of the internet was the heating up of the Cold War. I'm pretty sure you guys are familiar with that. So the Soviet Union's launch of let's say, the Sputnik satellite kind of spiked the US Defense Department to consider ways of to spread information just in case, even in the case of nuclear attack, right? So this eventually led to formation of what do we call today internet. The formation was it's called actually back in the day ARPANET, which stood for Advanced Research Project Use Network. But as of today, we know it as the internet. That's how it became today. Okay. And this is the first computer that I just talked about. This is here, the scale model of the UNIVAC. It's called UNIVAC 1, Universal Automatic Computer. And it weighed approximately, I think, 16 pounds, 16,000 pounds, which is about, I think, 7 tons. Yeah, 7 tons, 7,000 kilograms, right? And this was the first American commercial computer, actually, as well as the first computer designed for business users only. Okay. And if you take so like I said, this is a miniature version for you to be able to see the whole thing. Today, what our computers look like, it's just a smartphone. It's just your smartwatch or whatever, right? This is that small. And here's the actual picture of that computer. As you can see, it's ginormous, right? And these things here, as you can see, do you guys see my the mouse pointer?
Yes.
Okay, these are the tapes where you would store your data on, right? Today we have hard drives or flash drives, really small SD cards where we can keep our information. So these are called magnetic tape storage. As you can see, this is the way you stored the data. And these are the things that you had to travel with to be able to copy some data from other computer, or they had to ship it to you. Okay. But today, what do? We just use Google Drive, iCloud, what else? Instagram, WhatsApp, or just simply copy some, data from one computer to another computer, right? And these are the stuff, okay? And if you look at the data storage evolution, the first thing that you see on the left-hand side, these are called punch cards. This is the one that was used until 1950s, I believe. And this is from the UNIVAC 1950s or 1960s. This one is probably, you guys know, some of you, if you are old enough, the cassette tapes. Then it's your normal regular hard drives, if you remember. You might also remember this floppy disk, if you remember as well. You had a 1.44 megabytes or something like that. But today, we have stuff like this, really small. CDs and all that stuff. Right? So before we go into what the data footprint is, do you have any questions? Do you would you like to add something or ask? Okay. What is the data footprint and how we got here actually, in terms of what, why there are so many IT professions in this field? Data footprint basically refers to the amount of storage that is required for you to store the data, collection of data, your documents, your pictures, your videos, music collection, whatever, right? I think it's good enough just to mention this kind of stuff. And then in the next slide, actually, if you look at it, the total amount of data that is created actually by years, as you can see here, captured or copied or consumed when you are watching or whatever, right? If you pay attention, it's in terms of zettabytes here, and I will show you what the zettabyte, how big the zettabyte, the number itself. And if you pay attention, before the 2020, they projected that let's say the data consumption or data generation, the music or video, whenever you take a picture, you are generating some data, right? The prediction was that it's not going to be 64.2 zettabytes, but they were thinking that it will be way less than this. But do you guys remember what happened in 2020?
Pandemia.
What was it?
COVID-19.
Yes. Well, with the COVID-19, we started consuming a lot of data. We were creating a lot of data, right? A lot of everything went to the online style, remote, and all that stuff. That's why you see that spike here. If you take a look, I think it's about like 50% increase from the previous year, as you can see. Here's the projected data creation by 2025, 181 zettabytes. You guys are probably familiar with megabytes, gigabytes, and maybe terabytes, right? I'm assuming from your laptops and whatnot, maybe your external hard drive or stuff like that. So let me show you, just to give you a perspective on how big a petabyte or exabyte or zettabyte is. Let me show you this picture. So if you pay attention here, these are the stuff that you are familiar with, maybe megabyte, right? Your photos these days from your iPhone might be around like 5 megabytes, or it could be maybe even 10 megabytes, right? Just one photo, one picture. So if you pay attention here, as you can see, megabyte here's the petabyte, which is a huge thing. It's basically 1,000 times more than terabyte, okay? And then we were talking about the zettabyte. Do you guys see how huge this number is? And to put it into a perspective, I just found this great image. If you pay attention, it says 1 gigabyte is if 1 gigabyte was the size of Earth, then an exabyte would be the sun. And as you can see, it's ginormous, right? And it's talking about comparing between gigabyte and exabyte. In the previous slide, actually, we were talking about the zettabyte. Now imagine 1,000 times bigger than sun. That's how big data we're talking about. I can't even comprehend that kind of big data. But that's the data that we are producing, and this is the projected data by 2025, 181 zettabytes, as you can see from here. Okay. You will see why I'm explaining all this stuff. I'm sure maybe you guys are bored or something, but you will see in a little bit why I'm explaining it and why all these fields are coming up in IT field. There are so many. I'm not even aware of some of them. I can't even probably explain what does that field or profession does. Okay, there are so many of them. The next thing is digital footprint. Let me ask you guys: has anyone or does anyone know what the digital footprint is? Anyone wants to take a guess? Any ideas? Don't be shy. Just say
It's
it.
digital footprint is what we produce with our digital world, in computers, in smartphones, what we produce, for example, pictures,
Exactly.
videos, our emails, our letters, electronical, everything. I think that's, and I remember that was a case that is a Kyrgyz language, for example, it has no enough digital footprint.
Oh, really?
That's why,
Okay.
yeah, that's why it's very hard for AI
To train it?
to train it. Yeah, because
No.
AI it trains only in digital footprint, and
Yeah,
all
it
the
needs
data.
data to be able to train your AI model, right?
Yeah, and that's why that we should, for example, as a Kyrgyz people, we should produce more media and more things in our digital world in our language in order to make the opportunity to AI to train it.
Nice. That's a great answer. Actually, it's really it. I think it is the answer, and I can add up on that. It's basically digital footprint is basically all of the data and information about your online existence, right? Online presence. So whatever you do online, what we mean by digital footprint, right? It's the result of your online activities or interactions or your Google searches or whatnot, right? So it's not limited only for that kind of stuff. If you are posting some picture, if you are searching like Google search, or if you're shopping online, by doing all of that stuff, you are actually creating a digital footprint. It's like a breadcrumb thing, right? You are basically leaving a trace, and people, an analyst, the data analysts or some other folks, they can, using all that information, they can actually profile you. They can tell you actually a lot of information about you. So it's really important that you guys are aware of what you are sharing and what actually you are searching in Google search, because Google's business model is basically whatever you search, they have to provide you, or they have to show you relevant content, relevant advertisements, so that you can buy something or you can watch something, because all those companies basically pay Google, right, to be able to get information about you, so that they can target you well, so they can actually show you the relevant data. Correct? Everyone probably knows that, right? That's what we mean by digital footprint. By doing all of this, so it's part of all the data generation as well, right? All of the stuff, whenever you search something on Google, they don't go away. They are kept somewhere, right? So that they can, have some opinion, and they can sell your information, or they can sell or provide information on what you are most interested. So they can probably show you some product page from Amazon or from other shopping websites, basically. Okay. Any questions about this? And okay, and thanks to whoever created this beautiful and helpful visual here. As you can see from the picture as well, it is illustrating what is happening every minute. So I'm not sure how current or up to date this data is. Nonetheless, I think it's these are staggering numbers. These are, I don't know, these are mind blowing. If you pay attention, let's say take it as an example, Instagram. The per minute there are 65,000 pictures are being shared, and Google is handling 5.7 million searches per minute. All of this happening in 1 minute, right? And iMessage, I'm pretty sure you guys are familiar, whoever is using iPhone. Basically, Apple is handling 12 million messages per minute that are being sent between users, right? So all of what you're seeing is happening like every single minute. This is a great time to be alive, to be honest. There's so much going on daily. Whenever we're using all these tools or services like Netflix or Facebook, we don't think about this stuff, right? But once you come into IT, these might be, depending on the person, these might be really really cool things or numbers to see actually. So next thing, I would like to show you how much of a data traffic, internet usage we are doing, like daily or monthly, whatever. I found this image online. If you pay attention, I'm pretty sure when I'm sharing this through, like right now, I'm not sure if you are able to see this 1984 here. It's a really small dot, right? Compared to 2014 or 24. So in 1984, the total internet usage basically was 15 gigabytes per month. Do you think it's a US or the whole world? Do you guys have any?
The whole world?
Yes, it's the data, the internet usage in 1984. This is 15 gigabytes. It was for the whole world, right? But in 2014, the traffic is, as you can see from here, it says 42 exabytes. We just saw the exabytes, if you remember earlier. It's a huge number, as you saw earlier, right? So if you compare to this, to the 1984, it's a enormous number. I think it's about what, 2.7 billion times more than 1984. In today's world, guys, from this website, this statistics website, I think it's from Cisco's website, they say that every second per user, in today's world, it basically produces 15 gigabytes of data traffic, internet usage per user today. Back in 1984, it was the whole world which was producing 15 gigabytes of traffic, right? And as you can see from here, it says per user in 2014 was 15 gigabytes per month. Now imagine what it is today. I'm pretty sure this number is really huge in 2023. Okay, so we just talked about how we are creating data footprints, all this internet traffic, all this digital footprint. Why I went through all of this? Any guesses? Why did we just talk about all of this stuff? Anyone wants to?
Yeah, to show how the IT and the computer science is getting important day by day,
Exactly. Thank you. You didn't introduce yourself, but these are great comments.
Yeah, my name is Nursultan.
Nursultan. This is a great answer, actually.
Thank you.
That's exactly it, right? I'm trying to give you the perspective why there are so many fields in IT, like data engineers, network engineers, system engineers, QAs, SDET, software engineers, and all that. To be able to handle all of this data, if you guys remember from here, all of this, we need a lot of people, right? To be able to handle all of this. So in the simplest form today, what users do, they just open up their web browsers or laptop, whatever. You access some data on the internet, right? It might be overseas, it might be stored somewhere which you have no idea, right? Or you want to watch movies, shop online, search stuff, or you might be creating some memories by taking pictures and uploading them, I don't know, to iCloud or Google Drive, whatever you have. Or you might be writing some blog post, okay? To make all of this possible, there must be someone or some group of people, right, in the background that are really hard at work and they're making it possible. So who are these people? That's where we come into information technology, basically IT, right? It stands for IT, if you didn't already know. And as you might know, it's really hard to actually imagine in today's world where there's a company or some government building or whatever, government, whatever, where there doesn't exist IT at all, right? Even if you go, I think, into a trucking companies or some smaller businesses, they're still using some sort of IT. They may not have their IT departments, but for sure they're getting some services from other companies that support this type of businesses, like small businesses that they can afford, or it doesn't make sense to have the whole IT department, right? Because they don't have much. They just want to be able to use some service, and they want them to take care of it. Okay, do we have a question in? Because we're looking into DevOps. DevOps is all about cloud, I think. That is true. All the data is important for DevOps. That is true, and it is important for all of the fields. Especially the data is really important for data scientists and data analysts, okay? But all these fields work in synchrony to make it possible. To make it what exactly possible, we will see. And I just copied some, fields that I was able to find online. As you can see, it's a huge field. I'm pretty sure there will be like even more than this, at least like 2 or 3-fold more than this. Okay, and we will be only concentrating on software engineering, DevOps, maybe database business, help desk, maybe on cybersecurity. Also, when I say software engineering, I think I have it here. We will also be talking about the QA and SDET as well, just in case if there are some, like there might be some people among you, like they're interested in all of that, what each field does, what each field needs to learn, and all that stuff. Okay, this is the stuff. This is the really oversimplified structure. That's what you usually do every day. This browser or the computer might be your tablet, your phone, whatever, right? 90% of the time, I'm guessing you do whatever you do online. You just go to your bank.com or Instagram.com, Facebook, YouTube, whatever, right? And when you are doing that, there must be some server that will be responding you with the data. Let's say you wanted to watch some Titanic movie, that server has to send it to you for you to be able to watch that movie, right? So when we say server, just imagine there's a computer at the end of this, which will be responding you with this data or whatever you requested. Okay, so all of this fields in IT, they're working hard to make sure, some are working hard to be able to send you this data so that you can watch it. Some of them are working hard to make your data secure, right? So that no one else but you can access your data. Some of them are, securing and patrolling all of these infrastructures so that, bad guys or hackers cannot, break into the system and maybe delete your data or encrypt it and, ask for ransom. Okay, any questions, guys? Do you have any questions before we move on? Okay, I'm gonna go a little bit. If I'm going too fast, let me know. Okay, So far, what we have covered is actually only the facts, right? A little bit of history, facts, and research results, maybe, and some stats, maybe. So, and as you have seen on the previous page, there are a lot of professions, titles in this industry. So now going forwards, I will be talking about the stuff some of the titles do, like what software engineer does, etc. But before we get into that, does anyone know what IMHO stands for?
No.
Right? Do you guys know?
My honest opinion.
Yes. In my honest opinions, right? So exactly. But in this talk, I shamelessly took this IMHO from one of my favorite, the influencer or whatever you want to call it. He's one of the framework builders, or front end. I don't want to get into that much, but he's basically really good in front end engineering. So I took it from his presentations. In this presentation, this will stand for, in my humble opinion. Okay, so like I said, what we've covered so far was fact, history. You can research it. But going forward, I will be sharing some, opinions. And like I said, these are my humble opinions. Okay. I'm not sure if there are some of you that are coming from, let's say, from QA, SDET, or whatever, cybersecurity maybe. If I say something that might hurt you, I'm sorry upfront, but I'm pretty sure you guys will get over it. Okay. Basically don't forget my humble opinions. Okay, so let's talk a little bit about what software engineer does. Anyone wants to guess? Any ideas? Okay, if not,
They write a code?
yes, that's the main thing that they do, right? So I'm a software engineer. That's what I daily do at my job. Software engineers are the ones that actually write the software or the program that you are using in your daily life. It could be a program that you can download and install, or just a website or web application, right? That we are using daily, like your banking applications, social media, and transportation apps like Metro. If you guys are in Chicago, you probably know what Metro is. So, but so the software engineering itself, it has a lot of other fields within it, right? It's not just the software engineering, and software engineer does both back end and front end, and we'll talk about what those mean. But the basic structure in software engineering is what is called back end. We have here back end developer or front end developer. As you can see, I said here web. So back end developer is the one who writes actual, the logic of the software, saving, let's say, the data that you might have entered on the website. So let's say when you signed up for Tentech for this free sessions or info sessions, you probably entered your email, first name, last name, phone number, whatever, right? So that has to be saved somewhere, and that logic is developed actually by the backend developers. Okay, software engineers who happen to be backend developers. They do stuff like reading the data and making sure that users can access their own data, unless the data user is trying to access is publicly available. Maybe you are trying to access some public data, and that's fine, from news website or YouTube videos, right? But front end developer is basically a web developer, okay, who develops the website. All that you see online, that let's say you logged into your Facebook, that application, that the front thing that you see on the website that we call, that is being developed by a front end developer. Okay. Like I said, software engineers, they specialize in two different fields. Usually we call them back end developer and front end developer. Front end developer does actually do the whatever you see on the website. Okay, their job is to get the data from you and just send it back to the software that backend developer has written. Okay, and get the data that the software developer written, let's say server or whatever, the software that backend wrote. It will send the data, and front-end developer's job is basically to get that data from the backend and present it to you in a really nice way so that it's usable, so that you can click somewhere and do some actions, right? You might be renaming your, let's say, username or something like that. The only job of the website or the web application front-end developer takes the data, takes the actions, whatever you want to do, and sends it back to the software that is listening. And if you guys remember, we just saw the server where the user types in some requests, and there's a server which is listening to all those requests. Okay. Even when you leave some like on Instagram on someone's photo, or you just leave a like on a post, or let's say you save some music or video to a playlist, all of that information, all of those action has to be taken and delivered to the backend where all the logic lives. Does that make sense? Did you guys
Yes.
understand what I'm saying?
Yes.
Okay, great.
Yeah, it makes sense. How about the API? Does that to backend or to the front end?
So we're not going into those details, but API endpoints are being created by backend developers. And by using those API endpoints, basically contracts, right? Imagine having a contract in between backend developer and the front-end developer. So whenever front-end developer wants to send some action, or let's say would like to save some data from the user, there are some contracts. Front-end developer knows where to send that action. And that's where the backend developer expects the actions to come in, or the data that you're saving. It's the same thing. Whenever you go to an ATM, you see some visuals, right? You see some buttons and all that stuff. That's all visual, right? It could be a website, it could be some desktop application, doesn't matter. Whenever you want to, let's say, withdraw some money, so you just say, I would like to withdraw, let's say, $100, right? Your action, your intent is taken and sent back to the backend. And backend, the developer that has written all the logic in the backend, it has to check for a lot of stuff. And we will talk about this in a QA as well. It has to check, do you even have $100 in your account at all? If you have that amount of money, then it's going to allow you to withdraw money. But if you don't have, let's say you have $80, it's not going to allow you to withdraw that money, but because your account will be in the negative, which is not a state that we want to be in, right? So all of that interactions go between backend and the front end. Okay. These days there are not many, the desktop applications. So everyone understands when I say desktop applications, right? Desktop application is basically whatever you download from internet and install on your computer. It could be your Microsoft Excel, Microsoft Word, or your email client. What else? Some music player. That is called desktop application. But if you open up Chrome, Safari, doesn't matter. You go to some website. That is what we call website, right? So there's a distinction. Yeah, browser. On your browser, you go to some website. You actually don't download anything. You just do whatever you want to do on that website. You can access your bank account on a website on the browser as well. But they might have, like, on your phone, you actually have your application, right? Instead of a browser, you download Bank of America, let's say, application, and you sign in from there with your Face ID or whatever, and you actually do your intentions or whatever you want to do on your mobile phone. Like I said, there are a lot of stuff going on in software engineering, as in every other field, in DevOps as well. And Betul will be the one who will be talking about all those different areas of DevOps, okay? So just to recap, software engineer at the top, it has back-end development, front-end development, then it has a full stack developer, okay? Or mobile application developer. Like there are specific fields, like I said, because there are so many tools in IT in this industry. It's really hard for one person or for a couple people to learn all of that stuff. That's why we have so many fields, right? When we come together, we actually make things work. Otherwise, imagine I have to build the web application. I have to build, let's say, mobile application as well, and I have to create all the logic that is happening in the background. It would be overwhelming for me because there are so many stuff and there are so many platforms. So once you build an application for Android, you have to build another one for iPhone. There are some other technologies that you can do one build and it will produce application for all of them. But in general, what you usually do, you have to know some other language to be able to build Android application and some other language, programming language to be able to build iOS applications, iPhone apps, basically. Okay. And you might also hear the term full stack developer. We actually heard it earlier when I introduced Akrol. He will be going over some stuff about the DevOps roadmap. Basically, full stack developer is the one who can do the backend and the front end as well. That's what we call full stack developer. Okay, I hope this is clear. I hope I was able to actually explain it to you. What are the difference in software engineering? As you can see from here, software engineers, they have to know at least one programming language. Using that programming language, they will write some code, which is here. So that code is actually becomes the software or the program or website that you actually use. Okay. This is a really in simplified terms. I hope I did not overwhelm you. Do you guys have any questions about this? Let me check the chat. Okay. Any questions?
So the Sadar? Yeah, it's me to ask. So my question is, a software engineer can create like any applications for phone, for computer, right? Or
yes.
Or for the computer, or for the phone goes like specifically some sort of the engineer or software engineer doing in general all of these things.
Yes. So it is usually expected that, let's say, so I have done in my career, I have done mobile application development as well for iOS and Android as well. So I do full stack development as well. Even at my job today, I can, because I know the front end and the back end as well. So usually the idea is once you become a software engineer or once you learn some programming language, it's usually easy to learn some other programming language, right? If I wanted to, let's say build today Android application, I can just spend let's say 1 week or 2 weeks just to get me started, and I can build some simple application in really short time, because all the programming language at the end of the day, they do the similar thing. Okay, so you will be able to do whatever, and the companies would usually expect from software engineers to be able to adapt to changing requirements. Today they might ask you to build something with some programming language. Tomorrow they might just switch to another programming language, and you can't say usually no unless you want to leave or something. Like I said, it's usually not a big deal when you're learning when you know one language. It's really easy to get to learn some other programming language. Any other question?
Hi, Serdar. I've got a question.
Yes,
Can you
please.
tell in couple words what was the main difference between backend and front-end developer?
Okay, front-end developer, if I were to tell you like in simple words, front-end developer is what you see actually with your eyes, right? There's some visuals. There are some Sorry, let me mute. Okay. So whatever you see as a visual, buttons and login pages and all the forms that you are seeing, that's the front-end job, front-end developer's job. They build front-end website using CSS, HTML, JavaScript languages. But all the other logic that you don't see that is running in the background, that is being developed by the backend developers. So when you open up a YouTube, right, you search in YouTube something, correct? There's a search bar where you can enter your text. That's front-end developer's job, to present you with a search bar and where you can type in and search for videos or whatever. So whenever you type in something, right, let's say you are searching for some music video, it will take your text and it will send a request. We say request. It will send a request to the backend. Backend meaning the server that I just showed you earlier. There will be some software running, and it will send that text to that software. Software will search the database if it has any matching videos or music, whatever you were searching, and it will send the data back to the front end, to the website. The front side actually receives a lot of bunch of text, and it actually presents you in a really nice way, right? It will show you some thumbnails of the picture of the videos where you can see who, the artist maybe, or whatever the video content might be. That's the job of the front end, to show you in an elegant, in a beautiful way, the information. Does that make sense?
Yeah, it does. Thanks.
Okay. Yep. What is the most common pro language for the DevOps person? Thank you. Okay, it's always, most of the time, it's Python. Okay, and we will talk about the programming language on Thursday. Python is the most popular language probably in DevOps, in data analytics and data science, web developers as well, and some backend development as well. Some of the YouTube's code actually were written in Python. I'm sorry. Also, the Go language, like Sultan or Ruslan responded in the chat, Go is becoming really popular as well. Go is a programming language which was developed by Google, I think in 2011 or something like that. But Python has been around for, I think, at least 30 years now, 1994 or something like that. I can't remember the exact year, but yeah. And it's super intuitive, super easy to learn, actually, Python. So when I say super intuitive, super easy to learn the language, I'm talking about all the stuff that you have to write. So daily, I write Java code. Java is another programming language. It's way hard to learn Java as opposed to Python. Okay. Okay. And we have Salesforce developer. Has anyone heard about the Salesforce? I've just included the Salesforce developer just because you can find a bootcamp for Salesforce development as well. Are you guys interested, or you don't have any interest? If not, I can just skip it because I'm not interested in Salesforce either.
Mr. Sadar, yeah, if it's
Yes.
Salesforce development, I've heard that's some sort of the marketing job, right? And how to represent the software, how to sell it, how to trade it.
I think the companies that usually use it as a, I think it's called CRM or something like that, customer relationship something.
Right, for
So
representing.
Yeah, so it's basically some software that was created by whoever, I don't know. And in order for you to be able to, let's say they have 10 fields where you can enter some data. And if you wanted to change it and customize it for your company, you need to learn the language for Salesforce. It's Apex. I think it's called Apex programming language, which was built on top of Java, okay? So like I said, these are my humble opinions. So if I were you, if you are going into a development area, any development, I would stay away from Salesforce because it will be a niche market. So it's a niche market, so it could be a pro and a con, right? It could be a positive and it could be a negative. What is negative? The negative side of the becoming a Salesforce development is it's a niche market. You have to learn only Apex language, right? Apex programming language. Once you learn the Apex programming language, the only place you can build applications or you do whatever, it will be only for Salesforce. So you can't, as far as I'm aware, I don't want to be, I know all of this stuff. As far as I know, Apex is only usable to be able to create this Salesforce applications or whatever. So why would you limit yourself if you want to go into a developer area? Instead, learn Python or learn JavaScript, and you will be way better off. Okay, you will be able to use that language anywhere. But once you learn Apex, you are pretty much constrained to the Salesforce. So what is the positive side of this? The positive side could be because people think that it's a niche market, they don't want to learn this Apex programming language. Maybe there will be less competition. I don't know. But last time when I checked, just to prove my point to my friend of mine, I think there were like 12,000 on LinkedIn, as opposed to 4,000 for Salesforce developer or administrator or something like that. Even the QA estate job things were a lot more than Salesforce. So it's up to you. Like I said, assuming you guys remember this, these are my humble opinions. Anything else about Salesforce or any of the topics that we just talked about? What about games like PC or okay, if you wanted to become a game developer, right? Like I said, software engineering, and there are a lot of branches. If you want to become a game developer, you need to learn, most of the time it's either C# or it's C++. Okay, C++ is one of the hardest languages, I think. C# is still maybe manageable. Depends on what you actually want to do. Okay. Anything else?
Hi, may I ask one question?
Yes, please.
Yep. If I choose to go with the next batch, for example, do I have to choose which developer I want to be, or they're going to be everything? You're going to teach everything?
Okay. Yeah. Let me. That's a great question. Thank you, by the way. So let me clear out something, guys. I'm just talking about the IT fields. Our bootcamp is DevOps. Okay, it's not related to developer. You're not becoming developer. You will become a DevOps engineer. Once you graduate from our school, you will be learning whatever the tools and stuff needed to become a DevOps engineer. So becoming a DevOps engineer much easier than becoming software engineer. Okay. So pay attention to what I just said. I did not say DevOps engineering or SDET or QA, whatever. I did not say it's easy, right? I said it's compared to software engineering, it's a lot easier. Okay, there's a distinction between those. Okay, does that answer your question? I'm sorry, who asked the question?
Thank you. Yeah.
Yeah, so you will be DevOps. You have nothing to do with all of this.
Mm-hmm.
You will be learning Python, but no Java or anything like that. And like I said, we will come back to these IT fields on my second session, which is on Thursday. Okay. And I'm going to clarify exactly what each field learns, or what each field has to know, at least some bare minimums, let's say. Okay, let's switch to testing. You guys have probably heard, because I've included testing as well, because you can find some boot camps that are actually, I think, a lot more like SDET and testing boot camps than there are for maybe DevOps. I don't know. Testing, simply put, testers are the people who make sure that the developers, software engineer who wrote the software, they understood the requirements right from business people or from whatever. If you are business owner and you want software developer or a website for your business, you ask software developer to, or front end developer to build a website for you, and you give clear requirements as much as possible. You say, I want the button here. I want to make sure that people are not able to log in without if they don't have any account and stuff like that, right? So tester's job is actually to test the software that software engineer wrote, to make sure that there are no passes where the user can bypass or something can go wrong, basically. Okay. As an example, let's take a bank example as well. So one should not be able to transfer or withdraw money, right, if their balance is zero. Correct? So sometimes it gets really complicated. As a software engineers, we can sometimes forget some edge cases. Maybe we didn't check if, before allowing withdrawing money, maybe we forgot to check if the user has any money in their balance in the first place. Because it could lead to some weird situations that you would not want to be in. So, or maybe it could actually be when shopping, right? When shopping from application or like software or your application website, whatever, should not allow you or the user to add more items than you have in stock. Let's say you have 5 backpacks or t-shirts in your stock, but user is trying to buy 6 or 7 or 10 of them. So your software should not allow them to be able to add them, or they should not be able to change their prices. Okay. All of this stuff, that what the testers do in basic terms. Same idea with your Instagram. I specifically chose these applications because you guys, most of us are familiar with this kind of stuff, right? If let's say there's a user John on Instagram, then Instagram application really shouldn't allow some, let's say, random user to see John's, whatever John is sharing, right? If that random user is not part of his friends list. Let's say if John's account is private. Correct? So that's exactly what SDET and QA does. So what's the difference between QA and SDET? QA is usually, when we say QA, it's a manual tester. Basically, there's a person who will open up the website or application and click around, and they will basically try to break your application, right? They will enter some unexpected data. Let's say if you build a calculator, testers, QAs will test, let's say they're gonna test 5 divided by 0, which is undefined, right? Or 0 divided by 0, it doesn't matter. Your application, your software, instead of shutting down, it should be able to handle those kind of situations. That's what the QA manual tester actually tests. It will input some correct data, the data that an application or website is expecting, and then they're gonna test it with some weird data, like dividing by 0 or something like that. Or if it's a shopping website, they will try to add to their shopping cart, let's say, if there are like I said, 5 items available, they will try to add 10 items, and they will check if the software allows them to add or not, or no. If it allows, right? If it basically allows to, let's say, divide by 0 or allow adding more items to a shopping cart than there is available in stock, they will go back to a software developer engineer and tell them all the situations where you found unexpected results or behavior. Then software engineer, developer, they have to fix that edge case. And that's how all of these hackings and whatnot usually happen. That you might be hearing about, and how hackers got into somewhere and all that stuff. Okay. Yep. The question? No. Any other question? I can't talk about the because I have no idea of how much salaries they get, but according to one website that I found, looks like QA people can make between 40 and 120,000 a year, and estet can make up from 120 maybe up. Okay, depending probably on location or company. So what's the difference between the QA and estet? Estet stands for basically software developer engineer in test, I think. Yeah. From estet, it is expected to write some code. So let's say if we take Instagram as an example, I think a year or 2 years ago, we didn't have actually a feature where you can put filter on your face or whatever, right? Yeah, and we didn't have a ability to see some. We didn't have basically reels. Reels were not there, I believe. So every time you add new feature, let's say some filter or something else. Do you guys understand when I say feature?
Yes.
Yes.
Okay, so whenever you are introducing some new thing, right? New functionality, new capability. Okay, what do you have to do? QA has to test, that specific scenario where you are adding new functionality. The problem is once your application becomes really big, every time you add new feature, you cannot test basically human being. You cannot test all the scenarios that were before there, just to make sure that nothing else has broken while you are adding this new functionalities or new capabilities, right? So for that, you need some sort of automation that will test it for you. That's exactly where the estet comes in, okay? They are expected to be able to write some test case scenarios. They are doing it by writing, as you can see from here, by writing code. They write code to test your application, okay? And it's automated. Before releasing a new version, how do you update your application? On your iPhone, you just go to the App Store. If there's an update, you just update. You just click update, right? Before releasing any update or new capabilities or whatever, they have to test it. So before even building new version, there's automated tests that are running in the background. If for some reason, if any of that test cases that the estet wrote, if for some reason any of them fails, new version basically doesn't build. So they have to check what has changed and what has failed. Maybe while the software engineer or developer, when he was adding a new capability to be able to add a picture filter or reels, maybe they broke something else. Okay, like I said, it's really complicated. There are a lot of code, God knows how many lines of code. So it happens. Okay, that's why we have different people who are responsible for different things. Did you guys understand the difference between the estet and QA? So if they tell you estet actually is not that hard, or you don't have to worry about or whatever, if you are actually employed as an estet, they will expect from you some coding. Okay. So like I said, in the next session, I will make sure to include actually what tools estet or
What
any
about-
other. Go ahead.
What about QA? Do you need to know how to code for QA?
No, but there are some tools that are expected from QA to know as well, like a database, right? So we have in our company, in my team that I work for, we have 3 QAs, and they are expected at least to know some tools. And we will talk about those in the next session. They are at least expected to know, let's say, database, to be able to query some data to get from the database. They're at least expected to understand or, how to navigate inside of the Linux operating system. And they're expected at least to understand, I think, the Git tool. Maybe we will go into that, but like I said, because these are the more of an info session, I don't want to overwhelm you guys what they actually do, like what the Git is or something like that. Maybe some of my other colleagues, the speakers, they will explain you. But I think that's basically it for QA and STAT. QA, just remember, it's mostly, when you say QA, it's people will understand manual testing, okay? Click here, click there. Let's say you have a light theme or dark theme on your website. When I actually click the dark theme, does it actually switch to a dark theme or not? Or if your website supposed to switch automatically to a dark theme after, let's say, 7 p.m., you can test it. You make sure that it actually works, okay? We have a question in the chat. How is job finding help will work? I saw on general chat, it says you will no longer help after some time. So I'm not sure if you are referring to like a job placement or anything like that. Like I mentioned in the beginning, in these sessions, we will not be able to answer this type of questions, okay? Nor my colleagues or speakers will be able to answer that kind of questions. What you need to do is call Sultan or Ruslan for that, because I have no information on that. Okay, that's a good question. What's your opinion on AI and DevOps field? I'm pretty sure you guys probably heard of AI. Is everyone DevOps? Okay, I'll answer the next question in a little bit. But what's your opinion on AI and DevOps field? What do you guys think? Anyone has any idea about AI, artificial intelligence?
Mr. Sadar? Yeah.
Yes.
Is there any chance that the AI will automate it in the future as DevOps skills, as a DevOps engineering, will do everything instead of the actual person, the AI? What's the chance of that for future? I mean, it comes for 5 to 10 years.
What's the chance of AI replacing DevOps, right?
Right.
Okay. I can answer in all of the fields, my opinions, let's say. I don't want to take a guess and say, you know what, don't worry, AI will not do anything. I don't know. I don't want to be in that position like 15 years later. Someone will say, you know what, this dumb guy said that AI will not dominate or whatever. I don't want to be one of those persons, okay, people. So what I think is, if you guys remember, are you guys familiar with the industrial age here in the United States? People were afraid that, with all these machinery and all that stuff, they will lose their jobs. There were a lot of people were basically scared, right? Because of a lot of these tools, automations, and industrial machines that will, that does a lot of the jobs people do. And in reality, if you take a look back, it actually happened, right? It replaced a lot of people's job, but at the same time, it also created some other opportunities in terms of jobs. Now people had to, maintain those machines because they need some maintenance. Now there were jobs available for people to operate those machines. So what I think is, I'm not sure. I don't think DevOps or software engineering, or let's say, will be replaced by AI. But in today's world, in software engineering, we use, and there are a lot of other fields that use AI to, assist them in terms instead of replacing them. Okay. I think the first field that might be replaced would be QA. Okay, I think it can probably do a lot of stuff. The testing and all that stuff. Maybe I think that will be the first thing that might be replaced with QA, and maybe SDET as well. Given the application and the requirements, maybe it will be able to, code up your testing code. It probably will be. I mean, will be able to produce some test scenarios for you. But in terms of DevOps, it's really hard to say. I really don't know. We will see, and we will even see. But I think with the AI's advancement, maybe there will be the same situation, same scenario as the industrial age. Maybe there will be some new job titles that we will go after, I think. Does that answer your question? I'm not sure, but it's really hot topic actually.
Right. Is there any case for today that the AI replaced any engineers, considering software, DevOps, and
No.
Not any case yet, right?
No, usually it's really hard to gather the information, or even when you want some software to be written, the business people or the user who actually give you the information of what they actually need, they're not really clear. Even users, they don't know what they want. But once you start building some application, then they start telling you, oh, you know what, I actually wanted this one, or I didn't want this button here, or whatever. If you probably can give some clear-cut, really great requirements, maybe it can produce, but I don't think in the next 5 or 10 years it will be able to totally, get rid of IT fields. I don't think so. We will probably more use it as a tool, and that's how it's being used in today's world. All these software engineers and all of them, they're using these AI tools, Copilot, and there is a Google's Bard, I believe. I think
DevOps engineer also we're gonna use.
Yeah, they use as well. Whenever you get stuck, instead of searching on Google and trying to find which link might be the answer for your question, instead they are asking AI tools. The key point is you need to be able to explain what exactly you're asking. If your question is vague and you leave some open-ended question, I'm not sure how successful it is.
Great, thanks so much.
Okay, sure. Then there is another question from Kanike. I hope I'm pronouncing it right. So she says, I think, how many languages should know DevOps engineers to be a professional in their field? How many languages do you know? Thanks. Okay, DevOps engineers, I think in today, if you really know like a Python, if you learn Python, I think it's really enough. Like I said, there are some people who actually use Go, but I think like 90%, if not more, they use Python. Actually, like I said, you've already seen our speakers. You can ask them the same question as well on their sessions. They are today they are working as a DevOps engineers, cloud engineer, DevOps engineers. Better will go into more detail about it's the same as we covered in software engineering. We have different branches. Basically, DevOps has different branches as well. And there you can ask them. They actually use Python. And how many programming languages do I know? I think I know about 5 or 6 programming languages. I believe so, yeah, 5 or 6 probably. But actively, I'm using only 3 of them, okay? To build a website and my daily job, which is a Java. And whenever I'm solving some online questions or some puzzles or whatever, I use Python. Because it's really, you will see, it's really easy and intuitive. You have less typing in Python compared to, let's say, Java. That's one of the reasons. And like I said, Python is being used by a lot of fields: data science, data analytics, There are some places that use Python as as their main language. So there might be some STED and QA in Python as well.
Mr. Sadar?
But yes, please.
Sorry for the interruption. Continue. My question is, through the Python, are we able to create the software to use an iOS device or only Windows or the Linux? How does it work? So, and the next question, the second question is, DevOps engineer gonna use only the Python, or we're gonna learn about the Java or the other tools as well?
In terms of programming language, DevOps only learns Python. They don't need any other language, okay? Unless the company you just got a job at, if they're using Go, I have no idea, but I haven't seen it, to be honest. Most of them, like I said, 90% of the time, maybe even more, they use Python. And I know that for a fact, okay? And when it comes to with Python, there are a lot of frameworks that you can use that are written in Python that enables you to be able to build web applications, that enable you to build mobile applications and some desktop applications, okay? So once you learn the inner workings of Python, you will be able to do all of those. And basically most of the languages, they will have some sort of other tool that you need to learn if you wanted to build, let's say, desktop application or web application or something like that. But you will be able to do it with Python. Any other question about the testing STED or whatever? Let's just go from here if you don't guys have any questions, and let me just cover about this DevOps. We've already talked about DevOps a lot, so I'm gonna leave it up to my colleagues. They will talk, like I said, Betul will be covering a lot of stuff that when it comes to DevOps, in terms of all the branches that the DevOps can have, or once you, let's say, finish DevOps bootcamp, all the positions that you can apply with just becoming DevOps engineer, okay? So I'm a software engineer. I can apply to front end. I can apply to backend developer roles. I can apply to full stack developer roles and all that stuff. Same thing with DevOps. You will be able to apply to all different branches, and it has quite a lot actually, okay? So they will be a great resource for you guys to be able to ask any questions that you might have around the branches in DevOps. And you can also ask the questions about, and they will actually go into their daily routines, what they do and all that, okay? We specifically chose those people so that they can answer some of your questions actually around the DevOps and other fields, okay? And then we have, I'm just gonna mention about the cybersecurity. I'm not sure, one of my friends, he might have joined today to this pre-sessions. I'm not sure. He works as a cybersecurity. To be honest, I don't even know what is because they have a lot of branches as well, as you can see from here. Systems analyst, data privacy officer, and I'm hoping that these are the correct branches for cybersecurity. I personally, in my bachelor's degree and master's degree, I learned a lot about the cryptography, keeping your data safe, and I know all of that stuff because we'll learn in computer science, basically the whole thing, not the specific cybersecurity or DevOps, but we get a lot of information basically. So cybersecurity, I just chose this word. Like I said, if you guys remember, my humble opinions, right? I see them as a patrol, right? Who are going around the building like a security. They make sure that bad guys, hackers, cannot enter to your building. They make sure that the data is being secured and in a basically walled garden so that no one can access the data but you or whoever you give access to. Okay, that's their basic. In simple terms, that's what cybersecurity does. And I think cybersecurity, they learn Python as well because they need to write some script, some small programs to be able to test something or to be able to actually, test or penetration testing. It's called penetration testing. I think they use Python as well. And they also use some other tools. Like I said, there are some common tools that all of these fields are expected to know. I'm going to repeat myself, and we will talk about those tools on Thursday. Any questions about this? Did you guys understand what cybersecurity does?
Yeah, Mr. Sadar.
Yes.
So as a DevOps engineer, we're gonna learn about cybersecurity, or we're talking about this in general about cybersecurity, about DevOps, about this.
Yes,
software
guys. Earlier, someone else asked in DevOps if you guys going to learn stuff to become a software developers. Like I said, I'm just covering different fields because these are the fields that you can find boot camps for. So I'm just giving you the clear explanation who does what. So cybersecurity is not related to DevOps. Software engineering is not related to DevOps or cybersecurity or QA or SDET, okay? They all do different things. Here at Tentech, we only teach, we only prepare you to become a DevOps engineer, okay? What DevOps does and all that, trust me, you will get a lot of that information from other speakers. That's why I don't want to go into those details. Okay, I'm just giving you like I gave you the example and my opinions about the Salesforce. I'm just giving you what example or just an opinion what cybersecurity engineer or whatever they do daily, or what's their job. Ladies and gentlemen, is it really clear what we're trying to explain here? We're doing this session so that you get a clear understanding what each field does, so that you can make a well-informed decision, as opposed to someone tells you that this field is easy or this field is easy, hard or whatever. I'm trying to explain you here what each field does and what each field learns. We will talk about on Thursday. Okay, looks like it's really clear. Thank you. Okay, then there is a business intelligence or data science, okay? Data analysis is the process basically of inspecting or getting the data or transforming data from one state to another. That's what the data analysis is. And basically modeling the data with the goal of discovering, let's say, useful information, informing conclusions, and when the businesses are about to make some decision making. So when we talk about the digital footprint, whenever you create all of this digital footprint, whenever you create or search for something on Google, on Amazon, it doesn't matter. Basically, we agreed upon that we are creating some digital footprint, right? All this information are being stored in database somewhere. And using that information, this data analyst or data scientist, they can give a good prediction or, let's say, good information about you or some population, let's say, so that they can target you really well, so that they can show you the stuff that you might be interested in. For example, a data scientist, let's say in the healthcare industry, they might be keeping electronic health records intact for hospitals, right? To have access to confidential medical information. They may also use that data to help healthcare, right, organizations make sound business decisions. Maybe they're gonna, order less medicine as opposed to, let's say they get quarterly they order, let's say 1 million of some medicine. But once they have some data, instead of ordering 1 million medicine, they can order, let's say 600,000, because they have the data which they rely on, and they can save some money. They can be more, how should I put it? They can basically make a more decision making. Let's say decision making is far better when you have some data, because you know you are wasting money by ordering 1 million as opposed to 600,000, right? You can save a lot of money by not ordering extra 400,000 medicine. Let's say it could be anything, aspirin or whatever, Tylenol, whatever. Okay. Do you have any questions, guys? I think we're at the end of our slides. So now I would like to dedicate some time for Q&A. I know it was really interactive. I really liked this session. I was not expecting. People are usually shy. But thank you for all of you guys who asked the question. Otherwise, it would have been really boring for me, okay? Usually I don't create any presentations or whatever. I just talk whatever I have in mind. But in my sessions, usually I do not do any presentations. We just deep dive, open up some terminal, open up whatever, and we talk about we actually learn, spend some time, and don't waste time on these presentations and all stuff. Any questions? Do we have a question? Thank you. Okay. Yeah. Now is the time to ask questions if you have any. Any questions? If you can ask instead of typing in the chat, that would be great. But if not, if you can't talk for some reason, that's fine too.
Yeah, I have a question.
Yes. Can you introduce yourself? Because I'm not seeing who's talking. I'm sorry.
Yeah, my name is Nursultan, as I said before. Just want to say about the tools that we should learn. I heard a lot about the Kubernetes, GitHub,
Okay.
And do you or do your bootcamp make a research, for example? Because I heard that by the way everything is changing, shortly in short period. For example, some tools are changing, some tools are trending, and do your bootcamp make a research? And for example, could you, for example, change the way of teaching or the program of the teaching in the process? Because, for example, what we are teaching today could be not so important, for example, after 6 months,
Exactly. So here's the thing, guys. That's a great question, actually. And if you remember, I actually covered it in the beginning of my presentation, in the session today. I told you guys I am the lead instructor here. I basically oversee and manage whatever we're teaching. So basically our curriculum, right? I keep track of our curriculum, making sure that we are up to date with the industry. What does that mean? In other words, I am making sure, and all of my colleagues, they are making sure that we are relevant to the industry, so that we're not teaching some tool which was obsolete 2 or 3 years ago. Okay. So that's why. And what is the advantage? Again, all of our instructors, including me, we are working in the industry right now, right? And we are aware of the tools that are trending, that are that are becoming more popular, or if they're getting out of the, let's say, industry. We keep track of all of that. So whenever we see some trend in the industry, we will obviously update our curriculum as well. But this doesn't mean if there is some, let's say, some tool popped up like 2 or 3 months ago, and it's just getting some hype, that doesn't mean it's trending, okay? When it trends, you can actually see it on the LinkedIn job requirements. That's what I think it's trending. Why? Because those companies are actually using it, or they're trying to get into it, right? Because let's say from the software engineering perspective, if you are a front-end developer, there are a lot of frameworks that are coming and popping up every now and then. I think is front-end developer field is one of the worst fields maybe to be in, because like I said, there are so many tools that are coming up. It's creating a lot of hype, obviously. But what is the problem? All the companies are still looking for React developers. Like 90% of 80% of the job posts, they are looking actually for React developers. They're not looking for Svelte developers. They're not looking for solid framework developers. Okay, so there has to be some distinctions made between hype and trend. Does that make sense? Nursultan or anyone else?
Yes. Get it.
So we definitely make sure we try to make sure that we are up to date with the industry.
Yeah, I get it. Because yeah, I think it's the important key of in order to get a success, and to find a job. Maybe. Thank you.
No, I totally understand. Yeah. So there's another question from Zoom user. I have no idea. There's no name. So he or she asked, does your QA program include practice? So who wants to actually answer the question? Does Tentech provide QA bootcamp? Anyone?
No,
No.
it doesn't quite, because you guys teach
only
people.
DevOps.
Only DevOps.
Exactly. Yeah. Real projects, obviously. We are doing real world projects. We have a final project as well. And at the time of the speaking, we're in the works or in the, talks of developing more projects. Okay. Thank you, Janelle. Like I said, guys, software engineering has nothing to do with DevOps. I mean, they interact with each other, but you're not becoming a software engineer by coming into our DevOps bootcamp. You will become a DevOps engineer. You will not become data analyst. You will not become something else. Like I said, on Thursday, I will spend a little bit more time in terms of what each field learns, and maybe I might comment on the which one is harder or which one is not that harder. Maybe, I don't know. So like data scientists, if you want to become a data scientist, you better be good at some math, and you should be good with statistics actually. Okay, let me just say this. I think that should give you some idea of data science. Data analyst is different than data science. So you need to understand, you should have a strong background, I think, in, this is my opinion, so in mathematics, statistics, and all that. Okay, there's another question. Yulia answered already. Where did you learn full stack courses? Okay, so yeah, like I said, I'm Yulia. Thank you. She already responded. Like I said, I have a background in computer science. I have computer science background in bachelor's and master's degree. Okay, so like I said, we don't, like universities or some places, they don't specifically teach you for, let's say, to learn some framework. Once you learn some language or whatever, you basically learn to actually learn something new. And let me add this. This field is not static. That means you have to keep yourself up to date all the time, even when you get a job. That's the good thing about this field. You never get bored. There are some other new tools that are coming up. So you always have to keep yourself up to date. Does that make sense? Thank you, Ruslan. Okay, so then another question from Kani K. What do you advise newcomers to write about their experience in their resume? Newcomers. Okay, guys, I'm not sure about this one. I can't comment on this question because I don't deal with the resume and all that stuff. I think this question is way better to ask to Sultan or Ruslan or Yulia. She will be conducting the day 7 session, and she will have a lot more information that I can provide. Okay, she is really great at this stuff. Anything else? Anything technical, you can ask me. And like I said, so you can ask questions around the DevOps and its branches from Betul and other speakers as well, but they will not be able to answer your questions about software engineering or some other fields, okay? Ernest might be able to answer those questions because I think he was a software engineer before, I believe. Then he switched to DevOps. But Betul and Yulia, they may not be able to because they're DevOps engineers, okay? I didn't give you my full background, but if I were to give you my full background, so I was a system administrator as well. I used to work with, managing all those servers, switches. I'm pretty sure these are the words you have probably never heard of or what they mean. That's fine. But what I'm saying is I'm really familiar with the DevOps or what DevOps do. I may not be a DevOps engineer, but I have a understanding of what they do. And I interact with them at my work all the time. Whenever we need to do something about our, let's say, servers or whatever. Any questions? Well, before closing it, if you don't have any questions, obviously. Well, first of all, thank you for joining. And like I said, I did not expect this interaction, but I really loved it. Okay, keep it the same. Ask questions. It's way better this way when there is an interaction as opposed to me just talking. Okay, I really don't like that. I like interacting with students and answering questions. What I also do in my sessions, I ask a lot of questions from my students who come to DevOps. I might ask questions before we get started every class or at the end of our session, stuff like that.
Sir Bar, can
Yes.
you hear me?
Yep.
Thank you very much. It was a great presentation. Highly appreciate.
Thank you.
We all can see that you are highly professional in whatever you're doing and explaining. Thank you very much. Hopefully we'll all be succeeded here and then we will learn the DevOps in best ways with your help and everybody's help here. Thank you very much.
Yep. Hopefully. Thank you very much. It really means a lot to me. Okay.
Yes, sir.
Thank you. Yep. If you have any questions, I'm still here. If not, I will see you guys on Thursday at 6 p.m. Just briefly, I will be talking about hardware, software. We will learn some components of the computer, software, and we will talk about the programming languages. And we will come back again to the fields, and I will talk about which field learns what. Okay, and all those common tools that I mentioned. So because I want you to be aware that even if people say you don't learn much in QA or SDET or some other field, they are actually lying because there are some tools that are common to all these fields. Okay, I really want you to be aware and make a well-informed decision. Thank you, Sasha, for great comments and feedback. I really appreciate it.